Hello, physics students. Welcome to the Magic Lab. Now, I know that we've already done a lot of physics in this course this year. We've time traveled, we've teleported, we've even learned some physics. But what we're going to do in this lab is something that really is pretty amazing. If you were here, you would really feel like it was magical. Because what we're going to be doing is we're actually going to be predicting the future. And what we're going to use to predict the future is even more remarkable. We're just going to use this metal block on a string, this little ramp, this little ball, a little tape, and a meter stick. And of course, some physics equations. And what we're going to do is we're going to use the physics equations first to figure out what we need about this ramp. We're going to figure out the speed that the ball has when it rolls down the ramp. No stopwatch, no photo gate, again, just the materials that I listed. Once we know that speed, we're going to move this ramp to a new location higher up. And we will use that speed, our equations, our physics analysis, and we will predict where this ball will land. And then we'll let it roll, and we'll see that we accurately predicted the future. And it is pretty cool. If you were in class, a lot of students say, wow, that's so cool when it goes into that can at the end of the experiment. But unfortunately, you won't have that experience because we're going to be doing it remotely. But hopefully you'll see it and get appreciation of that. So what we need to do is figure out, as I said, in part one of this lab, it says to set this all up. I've already done it for you. And then we're going to calculate the speed of the ball as it comes off the ramp, as I said, by following this procedure. So what we need to do is let this ball roll down the ramp and figure out, measure how far the ball goes, and then also how far it falls. Now, when this goes down, when it goes down, you see it hits somewhere here on the floor, and it's very hard to see. So what we're going to do is use a sheet of paper, land it somewhere around here. Now I'm going to tape this to the floor. Tape another one to the floor here. Just a couple pieces of tape, really, to hold it down. All right. And on this sheet of paper, I'm going to put what's called carbon paper. This is carbon paper, okay? To show you what carbon paper does, if you live like, I don't know, 30 years ago, maybe 40 years ago, you would know what carbon paper does because you would have used it a lot of times. But I left my pencil over here. Watch this. Another magical thing today. Oops. See that smiley face? There it is. Carbon paper. It makes copies of things through mechanical pressure. So it left a little bit of carbon in the shape of what I drew on top. I don't know if you ever wondered why when you send someone an email it says CC and then it goes to someone else instead of the intended recipient, or in addition. That stands for carbon copy. So you learned something. You made a carbon copy with electrons going to another person. Now the advantage of this carbon paper is what it'll do is when this ball lands on the carbon paper, it'll make marks like I did with the smiley face. I'm going to launch this ball 3 times, and it'll land 3 times. Oops, okay, I made more marks. So let me make a mark of the ones that are redundant. Okay. Let's do trial 2. And trial 3. And let's see how those look. Oh, wow, beautiful. Right on top of each other. So you probably can't see that, but what I have is something that looks like this. And I have to draw them bigger because the marker is more crude. But basically, the 3 hits landed and left marks on the paper down there. So what I want to do is, this is obviously showing me how far this ball went like this. But here's the challenge. If I want to determine how far it went in the horizontal direction, where do I start this meter stick? If I try and eyeball the bottom of the ramp here, it's going to be inaccurate, and I'm not going to be able to achieve the magic that I want. So what I need is this, a very crude device called a plumb bob, or you could say a plumb line. All it does is just hang straight down, and it's a little tricky for me by myself. I don't have a lab partner here, or I should say I have a lab partner, but you're at home, so you can't help that much. So what I do is I wait for this to stop rocking, and then I put a mark right where this hangs. Well, that's not a good one. There. It's going to be as good as I can get it by myself. So that tells me the exact point below the cliff where I should start my measurement. And then I'm going to just do like, kind of like a visual average of the 3 dots. Maybe I'll just take the center one. 39.8 centimeters. 39.8. So, oh, I messed up my magic lab. Okay. All right, let's do this. All right, so I wrote down that horizontal distance on my lab sheet. And then what I need also for, obviously this is a projectile problem, I have x, a measurement in x. I also need a measurement in some other direction. Hopefully you're saying, raising your hand and saying, you know, oh, it's in the y direction, and then you would be correct. This meter stick has a little extra wood. All right. Well, I know I said I would only be using the meter stick, but unfortunately I see this one, cheap one, is not very accurate. So I got to get out a tape measure, which will get this y distance more accurately. So I see about 76.3. 76.3 or 76.2 centimeters. All right. 76.25. All right, so I had to do this in marker because I got carried away with my smiley face, but you're going to go into the Google Stream and retrieve your own y height distance and your own x distance. From those two numbers, you're going to have to calculate the speed of the ball off this ramp. So notice you have 2 pieces of data. You're probably going to have to do 2 calculations. It's a projectile problem. If you don't know how to do this, look through your notes, how to get the speed. So go ahead and do that now, and you should get a speed on the bottom here. Okay, so what I'm going to do now that I have this speed, I'm going to move it to the new height. Use that speed to figure out how far this thing goes. and then see if it magically goes the right distance. So let me reconfigure the camera. All right, so what I'm going to do is lift this table onto this one. There we are. Put my ramp up here. Now, as I said, the magic is that we're going to predict where this ball is going to land, and we're going to basically get it into this cup. Now, the ball, therefore, is not going to be, we're not going to be aiming at the floor because this is above the floor. We're going to be aiming for the top of the can, and hopefully the ball goes right through the center of the top of the can, and it's in. So I need to get the new height. And basically now, but from the top of the can. So let me get the tape measure. A little tricky. 137.8. 137.8. All right, so let me write that down as my new Y distance. 137.8 centimeters. And again, that has to be converted to meters. And then I have my Vx. So I'm not going to show you how to do these calculations, but when you're all done, you should get a speed somewhere near 1 meter per second. Maybe it's 1.1, maybe it's 0.9, depends on your data. But for my ramp, and I wrote it out to a lot of significant figures, I don't want to round the magic away, right? I want to keep the precision so that we could see the magic happen. So now what I'm going to do is, from these two values, the Y distance and the speed, I'm going to use my projectile motion calculations to figure out the new location, the new distance in the X direction, and I'm going to put the can in that spot and hit it on the first try. Well, hopefully, right? Then that'll be the magic. So you're going to do that now. You're going to do that calculation. I am too, but I'm not going to show you, right? I want you to figure this out. So let me quickly do the calculation. And then we'll see if I did the magic right. So this is what I got. And again, I'm not showing you the calculations. You've got to take these two numbers to find a distance in the X direction. 0.535 meters or 53.5 centimeters. So I have to figure out or measure that range the same way that I did in the last part, meaning I've got to first get the plumb line to show me the point directly below this so I know from what point to measure. So I will reuse my smiley face, carbon copied, tape this down. Let me get my plumb line. Let's see if I could do this by myself. It's going to be kind of tricky. All right, there is the point directly below. Now, I need 53.5 centimeters away. So that is right here. All right, now I'm going to center the can right there. See that tape mark? I want the center of the can right there. And you see I didn't practice. Otherwise, there'd be trial and error. There wouldn't be any magic. Now, sometimes it's off side to side, and that's all right. We're looking at predicting the range. If it lands here and I move the can over this way or that way, I'm not really changing my prediction. I'm just making sure it's aligned horizontally. But I want to take my time All right, here we go. Let's see if the magic happens. So here we go. Oops. All right, that doesn't count. Okay, here we go. Magic. Okay, so there it is. I hope you enjoyed. I hope you enjoyed seeing that going in on the first try. Again, remember, what I did is I predicted the future, right? I measured over here, and then I put it to a brand new height. And only from calculations and measuring this height and the data from the last part of the lab, I put the can in the right spot. I knew where it would land, predicted the future, and the ball went exactly where the prediction went. Exciting lab, lots of fun. So what you're doing, there aren't any questions. All you're going to do is submit photo of this page completed correctly. Make sure everything is done in the way that we normally do calculations. Equations and units and all that stuff are all correct. And then taking this speed and transferring it for part two, because it's the same ramp, right? Same ramp, so it has the same speed up here, but the new height, which you'll get from the Google Stream and these two numbers. From those three numbers, you're going to eventually calculate this out and submit photos of these two pages. All right, so who said physics wasn't fun, right? So I hope you enjoyed the physics, and I hope you enjoyed the magic, which is saying the same thing, physics and magic. All right, see you in the next physics video.